Okay, so they're going to give us a graph, and we're to write the formula for the polynomial function, and we're going to write it in a factored form. So if you're thinking, oh, I'm going to have to multiply all these binomials out, no, because we're going to write it in a factored form. Okay, that'll be easier for us. So they give us this picture, this graph, write a formula for the polynomial function shown. So you want to first find the x-intercepts. Okay, that's the first thing you do. So we have one here at -3, we have one here at 2, and we have one here at 5. So those are the x-intercepts. Then we create the factors based on those intercepts. So we know we're going to have, I'll put the a in because we don't know what the a is yet. But I have a factor of x plus 3. Remember, it has to be x minus the intercept. So in this case, x minus a -3. Let me write that. X minus a -3. But I'm just simplifying it to x plus 3. All right, and then you're going to have a factor of x minus 2 and a factor of x minus 5. So those are the three factors that we know. And we're trying to find least degree. Okay? Now we have to look at the multiplicity. So the second thing to do, so first you look for the x-intercepts. The second thing is to look for the multiplicity. Now, they write out these steps in the book, so you can look at those if you want. What's happening here at -3? It looks like it's just crossing on through. So I'm going to say there's a multiplicity of 1 there. I don't need to write the 1, but it lets me know I at least did that. And then it looks like it's coming up and touching here at the 2. So that's got to have an even multiplicity. And so we're going to say the multiplicity is 2 because we're going for least degree. And then it's crossing through again, just kind of straight on through at 5. So we're going to say the multiplicity is 1. Okay? So we get our polynomial right now to say f of x is a. I still don't know what a is, but we're going to talk about that. And I'm not interested in multiplying out those binomials. I could do it. It would just take me quite a bit of time to do it, but we're not interested in that. We can just leave it in the factored form. So then the last thing to do is we've got to find a. Now, you have to find a based on some point, on a known point. So what other point in our picture here do we know? We know this point right here, the y-intercept. That point right there is 0, -2. And we're going to use that in this case. Now sometimes they'll just tell you a point. In this example, they want us to pull the information off the graph. So that's probably our best bet to find a point. You could try to guess what this point is or this point is. I wouldn't. I would just go with where I can see that it's crossing the y-axis. And another nice thing about having x be 0 is it usually makes the calculation a little bit easier as well. Okay, so we're going to say f of 0, we're going to use this point that we know, equals a times 0 plus 3, because we're substituting 0 in for x, 0 minus 2 squared, 0 minus 5. All right, that we can do some calculating with. Scroll it up a little bit. Okay, so we get a times 3 times 4, because if you take -2 and square it, times -5. That says, now, f of 0, we know what f of 0 is. That's the -2. So -2 is equal to all of that. Or -2 is equal to -60a. And so now we're going to divide both sides by -60. And we get a equals 1 over 30. Okay, so now we're ready to write the polynomial of least degree for this graph, okay? And we know it's the actual polynomial. I didn't talk about end behavior, but you can look at the end behavior, right? We know it's going to have an even degree, and there aren't any more turning points, so we're going to feel pretty confident about this. Okay, let me scroll up so we can write it. We're going to take that factored form that I have at the top, and then all we're going to do is put in the a part. So f of x is equal to 1 over 30 x plus 3, x minus 2 squared, and x minus 5. Okay, there's the answer. Okay, so hopefully you'll have fun with a problem like that. The tricky thing is finding a, but remember you're going to use a point that you know, preferably the y-intercept, but they may give you another point.